Hello guys, welcome to my YouTube channel Learn with Ali. So today I am going to start a MATLAB series in which I am starting from the basics of the MATLAB and then we will go to advanced level of the programming in MATLAB. And this video is actually the introduction about the MATLAB, and I am assuming that you don't know about the MATLAB anything. You are just opening the MATLAB first time, and I will explain step by step what is inside the MATLAB and how to do the first programming in MATLAB. And after that we will see that some experiment regarding the VTech. I have given the hardware part of the experiment in a monokit, so I will explain all the experiments which I have given in the hardware kit, using hardware kit that into MATLAB, as well as some other experiment also I will explain. And next I will give some IEEE papers re-evaluation system, like how to evaluate the papers for a scholar or PhD guys, that when a paper is given, how to reproduce or re-evaluate the paper in MATLAB. So actually this window is showing the how MATLAB, when you open the MATLAB first time, this window will appear where there is current folder. In current folder your files are saved. Whatever the files are you saving, it is saved in current folder. So for example, my folder is in YouTube MATLAB, so I can change also from here, choose any directory from here, E, C, D, etc., and it will follow the path. Next folder is workspace window. So before workspace window, I will explain command window. So here is command window in which you can write the program, a short program. For example, I have to write a program of summation of two digits or summation of two numbers. So I have to write x. I can directly write 5 plus 7 and it will give C 12. So this 12, the result is saved in workspace window. Similarly, when I can type x equals to 5, same thing, and y equals to 7, and if I write z equals to x plus y, then this will give you the same result, that there is a variable x, there is a variable y, where the variable x is 5, it is stored in the workspace window, y and z. So I can use like x minus y, I can also use x minus y, and the result is minus 2. So if I have stored x variable, y variable here in workspace window, I can use many times, because variable can be used anywhere. And so this is the command window. So if I have to write the program which is more line, then it is not actually benefited me. That is why and it is in everything it is showing the results. To suppress the result, for example, I am overwriting x equals to 6, then I am putting a semicolon here and then enter. So it is not showing the result, that is x equals to 6, like this here. And also you can also see that x equals to 6, earlier x equals to 5, now it is replaced by x equals to 6. And when I just putting semicolon here, it is not showing the result. So you can suppress the result. So if you are you need some 3 to 10 line program, 12 line program, you can just write in the command window also, that is and you can evaluate. But why we are not using the command window for writing the program is, when we close the MATLAB, it totally erased. So command window is totally erased when we just close the window. So if I want the program again when I open the MATLAB, so for that I have to use something else. So there is a command CLC. When you write this, the command window will clear out. So if you are not getting the same window, for example, that is when you open the MATLAB and you are not getting these windows, current folder, workspace, command window in this format, so you can go to here in the home tab. There is a layout, so you can click on default and you will get the default layout. Next, when I want to write some large program, so I have to write it in a script. So for the script, I will explain every this sub menus when it is required. So in the subsequent videos, when it is required, I will explain all the menus. So for the writing of the program, for example, something, so we have to choose new script. So you have to go to home menu, in which there is a new script. When you click on the new script, there is a untitled script is presented here. So before starting the program, we had to write some commands which is used. For example, clear all. So basically clear all clears the already defined variables. When I run this program, clear all, these variables x, y, the variables x, y, z, it all clears. So if I am running this program, there is 3-4 options. There is run command, there is run and advance command, and run selection, advance, run and time. So I will tell everything about this, how it works. So first I will tell you how to use this in run command. So after writing clear all, so when I click on run, it will prompt to save the file. So let's save this file as test. Then you can one thing notice that here is the file extension .m, and when you save the file in the MATLAB, it should be the .m extension. So already it is taking .m file, and so there is no need to extend like .m file. There is no need to add extra .m, and when you will save it, it saved in .m format already. So just I am saving this file as the test. Save this file, and so here it is test.m, and see the workspace window, all the variables which is already defined x, y, z are cleared. Next we are writing close all. So the purpose of writing the close all syntax is to close the previously running program in the background. So first we are clearing all the variables which is already defined, then we are closing all the programs which is running in the background. Then next syntax I will write CLC. I have already explained about the CLC. CLC is the just clear screen, so it clears the command window. For example, here CLC. For example, here I am writing something x h equals to 3. Next for this, and I am again running this program like run. So it clears the command window, it clears the variables, it closes all the previously program. So these three are just three syntaxes which are used frequently for the programming in the new live script or script. So next I will going to show some program to plot a simple sinusoidal curve. How to plot a sinusoidal curve in the MATLAB. For that, for plotting any plot, you require some x-axis and some y-axis. So we are defining the x-axis. For example, when I am plotting the sine plot with in x-axis as a time and y-axis as amplitude. So first we have to define the time. For that I am defining the variable t, equals to, so time, when we are taking the t, that is time, and then we have to define from where it starts and from which last, the initial point, last point, and the step size. So we are defining 0, that is the time is starting from 0 and it is going to with the 0.001, this is the step size increasing, and then going up to, let 1, right? So this means the time is starting from 0 and the step size, it is 0.001. that means the first point, like when you are going to plot any plot, you require x1 y1, x2 y2, x3 y3, x4 y4 corresponding. So x1, x2, x3, x4 is the time axis. So for example, here x1 is 0 and x1 is 0.001, x2 is 0.002, x3 is 0.003, like this. So step size, it is starting from the 0 and going up to 1 with a step size 0.001. that is, we are defining the time axis in this format. So now we can use this time, this is the time axis, then this is the actually x axis and y axis. Let's y equals to, now we can define, like we have to plot sine curve. So sine, this is the inbuilt syntax in MATLAB, and then for example 2 pi fc 2 into pi into, here we can use direct command, that is let 100 or 5 is the frequency, into t, right? So we are placing this semicolon to suppress the result basically. So if I am running this program, so you can see there is a t variable which is 10010, which that means it is going from 0 to 1, and there is 1001, that is 1001 points between 0 and 1. And similarly, corresponding to this t axis, there is a y axis also, that is corresponding to x axis, x1, x2, x3, there is a y1, y2, y3 which is stored in y. So to plot this y, we have to use the command plot. Plot x axis, that is t, and y axis, that is y. So when we run this program, let's run. It gives the sine wave, that is, it is starting from 0 and goes, the amplitude is 1, as we can see from here. The amplitude of the sine wave is 1, and hence it is going from -1 to 1 because peak to peak, and the x axis is going from 0 to 1, which is the x defined by t, that is from 0 to 1. There is a 1000 points, which is by combining these points, the plot has been this curve has been plotted, right? So next we can also change the amplitude, as if we want to change the amplitude of sine wave with the 2, so we can multiply here 2 into sine, and next we run. So we get, here you can see the amplitude is 0 to 2 and -2. So by this way we can change amplitude, and we can also change the frequency. If here we can change one thing also, here the frequency is fixed at 5 Hertz, that is why the 5 cycles were in the present in the x-axis, but we can define this in a variable like this. For example, here we can write f, and let's define f equals to, let 5, same thing. So if we run this program, we are expected to get the same sine curve as we already got, that is 0 to the minus 2 to 2, and this is 0 to 1. So here we have just taken the variable frequency as a 5, so we can change the frequency as 10, then we can plot the signal and we can see what's happening. Its number of cycles in 1 second from 0 to 1, this is 10. So by increasing the frequency, you can increase the frequency of the sinusoidal signal. Similarly, we can plot the cos plot, as we can write here cos. So by running this, you can get the cos plot. So note that sine is started from the 0, whereas cos is started from 2, because we have taken the amplitude as 2. So it's highest is started from the highest amplitude. So by this way, first you have to plot any signal, first you have to define the x-axis, then corresponding y-axis. Y-axis is the signal that you want to plot. So let's plot some other signal. For example, here I am writing it as a 1, and this is cos. Take another signal, let y1 equals to, this is sine, and I am just copy pasting this part. Here, so this is with the same frequency, only the difference is this is cos and this is sine. And if some other signal, let y3 equals to y plus y1, so we can this is y3 which is equals to y plus y1, that is cos 2 pi ft plus sine 2 pi ft. So this is the summation of these 2 points. We can plot here with t. This is y3. So if we plot this signal, you will get the sinusoidal signal whose amplitude, because the frequency is same here, so amplitude is going from, because both are 1 1, and the amplitude is going greater than 1, and the frequency is the same, because both the frequency of the signals are same. So by this way you can just plot the signals. Here is another way I want to tell you something, that you can specify the time axis t in some other command, like let's comment this. So when you are commenting something, that means when we run the program, that comment will not, the comment line will not run. So next we can write t equals to, there is one other syntax in MATLAB which is called linspace, that is linear spacing, and it goes to 0 to 1, and number of points which is 1001. I am putting the same number of points here as 1001 points already earlier we got. So this is the sum here, one semicolon. So this you can define the t by this way, or you can define the t by this way. Here both the t are same. So let's run this program. What you are getting, you will get the same sign, same curve here also, because we have defined the time axis with the same thing. So here what is the purpose of run and advance? Same thing. If this plot I am just copy and paste in some new manuscript, here you can just paste, and if you want to run this program without saving, then there is a run and advance. If you don't want to save this because you are working as some rough work and you want to save this without saving the program, you want to just see the result, so you can go from run and advance. So if you click on run and advance, you don't need to save this program first, so you are getting the same result here also. Because, and if you just run this, then it will prompt you for saving. You have to first save the program, then it will run, and if you don't want to save the program, then you can run and advance. So in this video, I think this is enough for the introduction, and I will continue from here in the next video, because the video length is increasing. So if you like the video, please like, share and subscribe my channel.